All right, today I'm going to teach you how to write electron configurations. Now, it's a little bit of a lengthy video because there's several aspects that I want to get across here. But first off is there are several rules we have to follow for writing electron configurations, no matter which way we do it. First one is electrons are lazy. They will fill the lowest unoccupied energy sublevel first and then move up. So there's an order to filling, and I'll get into that a little bit later, but there's the order. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, etc., etc. This is also called the Aufbau rule. Remember, electrons don't like each other. They're negative, and they're going to repel each other. So they will fill unoccupied orbitals in the same sublevel before doubling up and completely filling an orbital. Remember, an orbital holds 2 electrons. This is also known as Hund's rule. And lastly, electrons in an orbital, remember there are 2 electrons in an orbital, will have opposite spins, up and down. This is called Pauli's exclusion principle. So when we follow these rules, we will be able to write the electron configuration for any atom and element on the periodic table. Okay, remember back to our Bohr model when we said that the nucleus was at the center of a model where the electrons orbited around the nucleus in fixed energy rings, right? So, and the lowest energy ring is closest to the nucleus, the farthest energy ring is farthest away from the nucleus. So here's my first energy level, here's my second energy level, third energy level, fourth energy level. Well, we need to expand that a little bit because remember we said we're going to say that each energy level can have sublevels. So my first energy level only has 1 sublevel, right? And my second energy level has 2 subshells or sub-energy levels. And my third energy level has 3. And if I drew a 4th ring around here, that would have 4. So the easy way to remember this is whatever energy level in, that's the number of sublevels you have. And remember, we've labeled the sublevels the following: S, P, D, and F. So the first energy level only has the S. Second has S and P, third has SPD, and fourth has SPDF. Okay? Now remember, we also said that even though the energy levels are sequentially increasing, when they split, some of the energy levels some of the sublevel energies cross over each other. Not a big deal until you get into the 3s and the fourth and third energy levels on higher. So my first energy level only has 1 sublevel, the S, and therefore that's the lowest. My second energy level splits into 2, S and P, with P being a little higher than the S. Third energy level, S, P, and D, with the D being slightly higher in energy than the P, which is slightly higher in energy than the S. Now notice something here. The 4S is lower in energy than the 3D, empty. When we start putting electrons in, that'll flip around, and that's a little bit advanced for the high school learner, but when we start filling and writing our electron configurations, we're going to fill the 4S before the 3D, because remember, we fill up in increasing energy, and this happens to be that the 4S is lower in energy than the 3D. And then 4P, 4D, 4F. Now, if we look at our energy sublevels and energy level and sublevels, we have the first energy level only has 1 sublevel, the S, and only contain 2 electrons. Second energy level has 2 sublevels, S and P. One contains 2, and the other one can contain a maximum of 6 electrons. Third energy level, S, P, and D. 2 electrons for the max, 6 electrons for the max for the P, and 10 electrons for the max for the D. In the fourth energy level, S, P, D, and F, 2 electrons, 6 electrons, 10 electrons, and 14 electrons. And remember, electrons, there's 2 electrons per orbital. So if you were to write the number of orbitals for each energy level, we would have 1, 1, 3, 1, 3, 5, 1, 3, 5, and 7. So the F orbital has 7 orbitals. The F sublevel has 7 orbitals. The D sublevel has 5 orbitals. The P sublevel has 3 orbitals. And the S sublevel has 1 orbital. Okay, so now let's see how these filled. Remember, we put this diagram on the other page to show you the energy level. So now let's break this down into a little bit more detail now. I told you that each sublevel has a certain number of orbitals. The S sublevel only has one orbital, but the P sublevel and the D sublevel have multiple orbitals. So here we have only one orbital, but now the P sublevel has three orbitals, Px, Py, and Pz. You don't have to know that, but you need to know that there are three P orbitals. Now, how many D orbitals we have? 1, 2, 3, 4, 5. As I mentioned before, there are 5 orbitals in the D, and 1, 2, 3, 4, 5, 6, 7. 7 orbitals in the F. Maximum 2, maximum 6, maximum 10, maximum 14. So when we start filling these up, remember, we fill them up lowest to highest energy. So we're going to put all our electrons in the first energy level until we max that out. There's going to only be 2 in here max. 2 in here max. 6, 2, 6, 2, 10, 6, etc., etc. Right? So we could quickly write those in. We can only have 2 here. We can only have 2 here. The total here we can have is 6. 2 here. The total we can have here is 6. 2 here. The total we can have here is 6. Total we can have here is 10. Right? 10, etc., etc. Right? And then the last one here would be 14. That's the maximum electrons we can put in each one of those sublevels. Right? Once we exceed that, we have to move up to the next energy. So this is the order where we're going to be starting to fill these things up when we put our electrons in. So we'll start here. When we fill this up, we're going to move here. When we fill this up, we move here. Fill this up, move here. So just as the energy says, keep moving up slowly and slowly until we run out of electrons. Okay, so let's get a practice one on how to do this, right, for the energy level. So let's pick lithium. So here's lithium, and determine the number of electrons your element or ion has. So we know that lithium has 3 electrons. Then it says place electrons one by one into the energy level, sublevel, lowest energy sublevel first with the filling rules mentioned. So my first energy level and sublevel is here, 1s, so I'm going to put my first electron in here. And then I can't move up an energy level or sublevel until I max out this one. So I can put 2 electrons max per orbital. So there's my second electron. And then I can move my up and get my next one here, and I'm done. So I've occupied all of the 1s orbital, and now I've had 1 electron in the 2s orbital. All right? So that would be the first one that we've done. So let's try another practice one. Another practice one. Let's try beryllium, which would be the next one up. So beryllium has 4 electrons. Okay? So let's put them in here. First one we have to go here. Then we have to put the second one in. Then we put the third one in. Now, we can't move up to the 2p yet because the 2s still has a space left and it's lower in energy, so we have to put that electron here. So there would be your electron configuration for beryllium. 1s and 2 electrons in the 1s, 2 electrons in the 2s orbital and energy level. So let's try moving on to something else on the next page. Okay, so let's do another couple more examples before I let you guys try. So let's pick the atom of carbon, who has atomic number of 6. So how many electrons do we have? We have 6 electrons. So let's put them here, 6 electrons. And using my rules, I'm going to start at the bottom of my ladder. And so I'm going to put my first electron in here. And now I can't move up to the next ladder until I fill this part, so that's going to be down arrow. And then the same thing here, I'm going to put my first arrow here. I can't move up to the P because it's higher energy until I put my down arrow. Now here's where it gets a little tricky, right? We still have 2 more electrons to put in here. Now you may want to do this, but that would be wrong because remember I said the other rule was the electrons don't like each other. So if there's a space in the same sublevel, energy level that they can go to without violating, moving up a level, then they'll do that. So they're going to actually be this. There's 1 arrow here and 1 arrow here, right? And if you had another one, you'd put that one here. If you had another one, you would put that one here before you doubled up. Remember, electrons don't like each other, so they want to get as far apart from each other as they can. So they're going to go into empty orbitals before they double up. All right. So this would be the electron configuration for carbon. Okay, so let's try another quick example before I let you guys try it. Phosphorus, so it's the atomic number of 15, so how many electrons we're going to have? We're going to have 15 electrons. All right, so we're going to start the same rules again. Put my first arrow up and down, because I can't, now I have 13 electrons left. First arrow up, second arrow down. So I have 9 electrons left. Now here's where it gets a little tricky. Remember I said you have to put the up arrow first, up arrow first, up arrow first, because we're going to occupy as many of these orbitals first before we double up. Now you're going to put your down arrows. All right, so now how many electrons have we used up? We've used up 10. So now we go up here. Again, we can't jump up to the 3p until we finish the 3s, so we've done that. And now we have to finish putting the last 3 in here. And there you would be for your phosphorus. Notice you have 3 unpaired electrons right here. Right? And that would be the proper one for phosphorus. Okay, so it's very tedious to write a large chart like that. You know, if you had to write this whole chart all the time for every electron configuration, that'd be kind of tedious. So what we've invented is an easier way to do this, and we're going to translate the ascending lines for the energy level, energy and sublevels into straight lines as follows. So as we move across from left to right, that's going to be increasing energy level. And so all we do is we translate each one of these series of lines down into this. So my 1s becomes here. My 2s is my next energy up, so that's next to the 1s, right to the right of it. My 2p, I need all 3 of these lines. That translates down to here. My 3s gets translated down to here. Remember, now 1s is lowest, 2s is next lowest, 2p is a little higher, 3s is higher. Here's my 3p. 3p goes here. 4s, and then finally my 3d. All right. So from now on, we're going to write it this way in a linear line. You have to make sure you put the designation of what sublevel and orbitals you are in. All right, like this. But you're no longer going to be doing this. It's always going to be this way. Okay. Okay, so the periodic table will also be able to help you understand where the electrons are filling from energy level and a sub-energy level viewpoint, because the periodic table is built exactly to do this. Let's see how it works. So remember, when we start with our periodic table, the rows are the energy levels. Okay? So we start out with our first energy level, and how many sublevels do we have in our first energy level? 1. So there's only 1 sublevel. So here's my helium and my hydrogen, right? In my second energy level, how many energy sublevels we had? We had 2. There's my S sublevel, and here's my P sublevel. Notice how the P block elements are all on the right side of the periodic table. The S block elements are all on the first 2 columns of the periodic table. All of my transition elements are in the middle of the periodic table. Those are my D block, and my inner transition elements are all my F block. So any one of these elements here, these transition metals, we're going to have D electrons. All of these things are going to have my outer valence electrons are going to be my S. These are my P, right? Okay, good. So let's see how we fill here. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Now, why is the 3d filling after the 4s? If we go back to one of our previous slides, we said that the energy level for the 4s is lower in energy level than the 3d. Right? That just happens how it works. So we're going to always fill in the lowest energy first. So in this case, it's the 4s. And if you see here, the 5s will fill before the 4d. Right? And then the 4f will fill before the 5d. And that's just the way it is, right? So you don't have to memorize that except for the fact that the 4s will fill before the 3d and the 4p. So you can use your periodic table to actually tell you where you should be when you're filling your electron configuration. Okay, so at this point in the video, you're going to try it. So you're going to try to do these 4 elements, these 5 elements using the arrows orbital diagram. So that would be, remember, that would be the 1, you would write the lines here, and then you put your 1s, and then your 2s, etc., etc. So what you're going to do is you're going to copy the words down here, the elements down here, stop the video, do the electron configurations, and then when you're ready, start the video again, and then compare your answers to mine. Alright, so stop the video now. Okay, here are the answers that you should have gotten, right? And so hopefully you can read my handwriting here. I've given you the number of electrons that you should have here, and your arrow count should equal the number of electrons that you've put down. So there's the number of electrons for magnesium, number of electrons for cobalt, number of electrons for phosphorus, nitrogen, etc. So the number of arrows you have here should be the number here. And you also should be having 1s, 2s, 2p, 3s, 3p, 4s, 3d in that order. Remember, for the p's, you're going to have to write 3 different lines, right? Anything that has a p, you're going to write 3 different lines. For the d, you're going to write 5 different lines, all right? So if you didn't get this, you should go back and kind of review the rules and try it again. If you did, let's move on. Okay, as mentioned before, the periodic table kind of will tell you what your final configuration should be, right? What your final valence electron should be. So let's just pick a random element here. Let's pick calcium, right? I know from calcium that I'm going to have the following electron configuration: 1s2, 2s and 2p, 3s and 3p, and my last one, 4s, is going to have 2 electrons because it says right here 2, 2, 2, 2, 2. When I get to my D block, scandium is going to have D1, yttrium D1, right? Let's look at boron here. Boron is going to be P1, aluminum is P1, gallium is P1. Do you see the trend here? Anything in this column here, for example, anything in this column here is going to have P2 as its final thing, because I have 2 electrons and I'm in the P block, right? Oxygen is always going to be P4, but so is sulfur, P4. Selenium is going to be P4. It's going to be a different energy level, but it is going to end with P4, all right? So this is the order that they fill also in a more visual representation of each element. Okay, so writing up and down arrows and lines and all that is tedious. So there's got to be a better way, and we have invented a better way. Because all the scientist really needs to understand is what his valence electrons are and where they're located. So the arrows really don't add that much value to that. It just kind of shows you where their spins are and all that. But in reality, we only really need to know which are the upper energy level electrons. So there's a quicker way to go from here to there. So as remember, we wrote these all out with the up and down arrows, and they told us a couple of things. One is what energy level we're in. So here we are in the first energy level, the second energy level, second energy level. Down here we had electrons in the third energy level, etc., etc. So when we make our shorthand symbols, or the regular way to write the configuration, is we just need to understand what energy level we're in, what sublevel we're in, and how many electrons are in that sublevel. So here's a little code here, right? Let's just look at the code. The number represents the energy level. Okay, energy level. The symbol here, or the letter, represents the sublevel. So you will see S, P, D, and F, some here. And then the last thing that we're going to look at is this number right here. This number right here, that represents the number of electrons, I'm just going to pre-elect, in that sublevel. That's all we care about. How many electrons, what energy level are we in, what sublevel are we in, and how many electrons we have in that sublevel. Okay? So if you go back to your standard thing here, right? You've got two electrons in your first energy level in your s sublevel. So we have 2 here. You have two electrons in your second energy level, s sublevel. So that's 2 there. And you have 3 electrons in your second energy level, p sublevel, and that's there. So how are we going to write this out now? So when we do this, we just say, here's my energy level, here's my sublevel, how many electrons do I have? Energy level, sublevel, how many electrons I have? Energy level, sublevel, how many electrons I have? So all this arrow stuff condenses down to this, and we read this as 1s2, 2s2, 2p3. So let's look at fluorine real quick. We've got 9 electrons total. 2 are in the 1s, 2 in the 2s, 2 in the 5 in the 2p. So we have 1s2, 2s2, 2p5, etc., etc. Here's my last one here. Magnesium has electrons all the way up until the 3s level. There's 2 in there. So everything else below it is filled. 1s2, 2s2, 2p6, 3s2. And so you would just keep writing them out that way. Instead of having all these up and down arrows and spins and all that, it's just quicker to write it here. So you can just basically figure out where your element is on the periodic table. Everything below that is going to be filled. So you're just going to, by rote, write up to that and then figure out what the last valence set is. So in our case here, my valence electrons are all the third energy levels electrons. So that's just these right here. In my magnesium, the valence electrons are only these because they're in the highest energy level. All these are my valence electrons. All of these are my valence electrons. So anything below, the lower the number, that's not going to be a valence electron, right? Only the highest number is the valence electrons. So it tells you quickly how many valence electrons you have. I have 5. I have 7. I have 2, and I have 5. And if you look on the periodic table, you will find that these will correspond to the group that has 5 valence electrons, 7, 2, and 5, right? So that's what's more important about that than writing all up and down arrows. Okay, so how can we use our periodic table to quickly write a electron configuration? Well, here's how it works. Let's just pick an element here that's low. Here, we'll just start with fluorine. Let's start with chlorine. Okay. So I know from chlorine that we're in the third energy level. So to be in the third energy level, using my electron filling rules, I know that all of these electrons are going to be already filled. All of these sublevels are going to be, and orbitals are going to be filled. So I can just quickly write that out. I already know they're going to be filled. Why do I need to mess around and put a bunch of arrows? So I'm going to write 1s2, 2s2, 2p6, 3s2. Now I just have to count what my 3 p's are. 1, 2, 3, 4, 5. And I just write 3p5. And I'm done. That's how simple it is. Let's pick another one real quick. Let's try chromium. That's vanadium. Sorry. Let's try vanadium. Vanadium is here. So how do we fill this up? Well, we know my 1s is already done, my 2s is already done, my 3s is, and 3p are already done. 4s is already filled because we have to fill these sequentially. So let's just write them out real quick. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now I'm in the 3d orbital. 1, 2, 3. 3d3. I'm done. It doesn't have to be any more complicated than that. Find out where you are in your periodic table, right? Here's all my S. Here's all my D. Here's all my P. Right, this is my S also. Find out what energy level you're in for your element. Everything below that has to be filled because remember we fill sequentially. And then therefore just write that all out real quickly, and then just find the last where you are. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. Okay, so you're going to try it now with the shorthand. That's the 1s2, 2s2 thing, right? So quickly find the element on here on your periodic table. How many electrons does it have? Add them up. Figure out which energy levels are already filled. Quickly fill in the sequence, and then go from there, right? So when you're ready, pause the video, write the elements down, write the elements down, complete the task, and then when you're ready to get the answers, hit start. Okay, so here are the answers, and I just want to make a couple of comments. So if you got the answers correct, great. Now here's the other couple of things you can look for now. You can actually figure out which one your valence electrons are. So let's see where they are. Remember, they're going to be in the highest energy level only, right? And they're only going to be in S and P. So here we go. The highest energy level. So here's my 6 valence electrons for oxygen. So what's my highest level here? So 1s is not high, 2, 3s, and 3p. So bromine has 7. Valence electrons for magnesium, 1, 2, 3 is my only 3 here, so there's 2 there. Vanadium, now this is kind of tricky because you think, well, is it going to be D3? No, it's the highest energy, right? The highest energy is the 4s. Okay, so there you go, that's the 4s. There's only 2 valence. And the last one is aluminum, so we have 3. And that's the way to figure this out. So quickly you can spot this out real quick about which are the valence electrons and which are not, just by looking at which are the highest energy electrons in here. So hopefully you've got a better understanding of how to do this now, and you should be ready to tackle any more of these problems that they come your way.